Hey everybody, this is our polar unit and this is video 5. I'll write that down. Make sure that you've got the right note sheet available and we're going to be taking a look at some complex numbers. It is completely a review from Algebra 2. So imaginaries and complex numbers, they're very much related. Imaginary numbers. I is our imaginary number that represents the square root of -1. So if we square I, then we're squaring the square root of -1, and that's how we get -1. So we have this rule that I squared equals -1. That's your imaginary numbers. Your complex numbers are made up of real and imaginary parts. So a plus bi is in the rectangular form if it looks like this, a plus bi, where a is completely real, b is a real coefficient, but bi is the imaginary part of a complex number. If you write a number 5i plus 3, that is not in the correct form. You would have to rewrite that as 3 plus 5i. That tells us that 3 is the real piece and 5i is the imaginary part. Okay, so I've got some examples and I'm going to leave a few of these blank for you to try and for us to discuss right away. And that's going to be our check as to whether or not we know that what we're doing and we can move on. So by the end of this, if you can do the ones that I leave for you, then you've actually met the goal of this video lesson. Example number 1 is to simplify the square root of -25. Anytime we have a square root of a negative number, we actually have a representation of I. So I have I times the square root of 25, which is I times 5. We would write that as 5I. Example number 2 is the square root of -120. Well, this time I'm going to have to consider that the square root of 120 is not a perfect square. So I have the square root of -1. We have the square root of 4 and the square root of 30. The square root of 30 cannot be broken down any farther because the only factors inside of 30 are 3, 10, 2, and 15, and none of those are perfect squares. So therefore, I'm going to simplify this first part as 2i, and then we're going to leave the square root of 30. Example number 3 has a coefficient of 4, so I have 4 times the square root of -27. So I'm going to have 4 times the square root of -1 times the square root of 9 times the square root of 3. Now you may want to break this down. This might be something that you're used to, is just breaking it down like this and then circling a single pair. That's the same thing that I'm doing. I'm just writing mine as radicals, a product of all of those radicals. So this first part here becomes 4i times 3, or 12i square root of 3. Example number 4, -5 times the square root of -4. Well, I've got -5 times the square root of -1 times the square root of 4. Since -1 is I and the square root of 4 is 2, I've got -5 times I times 2, or -10i. Example number 5, 3 times the square root of -10. Well, 3 times the square root of -1 times the square root of 10. The square root of 10 cannot be simplified any farther because I have 2 and 5, or 1 and 10, and none of those are perfect squares. So this becomes 3i and then the square root of 10, and that's as simple as it can get. Example number 6, I'm going to write for you, and then it's your job to do it. So you can pause the video and do it now, or you can look this over after you're done with the video. So I'm going to have -2 times the square root of -98. Make sure you simplify that before you get to class tomorrow. All right, example number 7. I'm going to be adding and subtracting some imaginary numbers. Now that's different than adding and subtracting complex numbers. So I'm going to leave number 9 for you, and on this page also number 12. Example number 7 is the square root of -50 plus the square root of -32. I cannot add these together because the number under the radical, called the radicand, is different. So I have to first simplify each of these radicals and then decide if I can add them together. So I've got, right here, we've got the square root of -1 times the square root of 25 times the square root of 2. That gives me 5i square root of 2. Now the only way I'm going to be able to combine this with the next part is if I'm left with add a square root of 2 as well. So let's see. The square root of negative 1 times the square root of 16 times the square root of 2. So that leaves me with plus 4i square root of 2. Because I have both radical 2's, we're able to combine them one further step, and that becomes 9i square root of 2. Example number 8. 5 times the square root of negative 75 minus 2 times the square root of negative 12. So we'll break down the first one. 5 times the square root of negative 1 times the square root of 25 times the square root of 3. The whole first part becomes 5 times 5 is 25i square root of 3. The next one, I've got a negative 2 times the square root of negative 1 times the square root of 4 times the square root of 3. Again, if you wanted to break this down as 4 times 3 and then 2 times 2, you've got your pair of 2's, which makes the 4 that I've got. So in front here, I've got 2 times 2 times an I, so negative 4i square root of 3. Because they both have a radical 3, I'm able to combine them. If they didn't, I'd have to leave it here. This becomes 21i square root of 3. Example 9 I'm going to leave for you to try on your own. So go ahead and write this one down. I'm going to change colors. It'll stand out a little bit more for you. Okay, so example number 9. 3 times the square root of negative 300 plus 4 times the square root of negative 48 minus 2 times the square root of negative 16. Okay, example number 10, adding and subtracting complex numbers. When I add and subtract complex numbers, I'm talking about numbers in the form of a plus bi. When I add those together, I have to add the real parts and the imaginary parts. My answer should be in the form of a plus bi. Here we go. Example number 10. 3 plus 2i plus 4 minus 3i. My real parts in this case are 4 plus 3, or excuse me, 3 plus 4, gives me 7. My imaginary parts are 2i plus a negative 3i, so I get negative I, or negative 1i if you'd prefer. Example number 11. 5 minus 6i is one complex number, minus 2 minus I. I'm going to subtract my real parts. That's 5 minus 2 is 3. Then we'll subtract the imaginary parts. Negative 6i minus a negative I means I'm adding an I, so I get negative 5i. That is in standard complex form. Example number 12 is left for you to try on your own. Make sure you have it done before you come to class. It is going to be 3 plus I plus a negative 4i minus, oops, I'm running out of room, 1 minus 6i. All right, again, you can pause now or you can do them later. Number 13. Number 13, I'm going to be multiplying complex numbers. So when I multiply complex numbers, I'm going to actually multiply number 13, I'm going to multiply an imaginary number, and number 14, I'm going to multiply a complex number. When I multiply imaginary numbers, I'm going to multiply the square root of negative 5 times 3 times the square root of negative 7. So what's going to happen here is I have to take out the I, so this is I square root of 5 times 3I square root of 7. I couldn't do anything with the 5 and the 7 because they're both prime numbers and they can't be reduced. So I do have to now multiply the insides and multiply the outsides. When I multiply the insides, I get the square root of 35. When I multiply the outsides, I get 3i squared. In the beginning of the video, I said that I squared represented negative 1. So this has to be changed for a final answer of negative 3 times the square root of 35. Number 14, I'm going to multiply complex numbers. That's going to be, for example, 2 plus 5i times 1 minus 2i. So these are my complex numbers. You're going to multiply these just like you would any other binomial, but we will have to clean up the mess that's left over and combine like terms. So 2 times 1, negative 4i positive 5i and negative 10i squared. When I go to clean this up, grabbing a different color, is these two right here will be combined. So I'm going to have 2 plus I, and this one becomes plus 10. Why plus 10? Well, I squared represents negative 1. It's already a negative 10. So negative 10 times negative 1 is a positive 10. So I'm going to add that 10 for a final answer of 12 plus I. Remember, I'm going to leave my complex numbers in the form of the standard form of a plus bi. Okay, so for example 15, I'm going to have you do this. We're going to do, 3 minus the square root of negative 2 times 4 minus the square, or plus, I'm sorry, let's do plus the square root of negative 6. Go ahead and simplify that as part of your homework. Number 16, again, we're going to work with division. I'm going to divide imaginary numbers for you. I'm going to divide complex numbers for you, and I will leave you with number 18 to try on your own. Okay, number 16, how about the square root of negative 50 divided by the square root of negative 3? The first thing I'm going to do is I'm going to remove and simplify as much as I can. I can simplify the square root of negative 50 to be 5i square root of 2. And in the denominator, I've got I times the square root of 3. My imaginary numbers here do cancel out because I have an I in the top and an I in the bottom, but I do have to rationalize this. So I've got 5 root 2 after canceling out the i's over root 3, and to rationalize we'll multiply both the numerator and denominator by the square root of 3, leaving us with 5 times the square root of 6 over 3, and that is this complex number simplified. Okay, for example 17, let's get something in the form of a plus bi. So if I have 3 minus 2i divided by, how about 4i? Well, in order to divide this, I'm going to have to rationalize it because I represents a square root, and I'm not supposed to have square roots in the denominator. So as I go to rationalize this, I think, well, what do I need to multiply by to eliminate the I from the bottom? And all I really need in this case is another I. So I multiply both the numerator and the denominator by I. The reason I works here is because as soon as I get an I squared, my i's are gone because I squared equals negative 1. In the numerator, we're going to distribute. That gives me 3i minus 2i squared. In the bottom, I get 4i squared. Let's start cleaning that up. So the top, this becomes 2. So I'm going to write that in standard complex form. So I get a positive 2 plus 3i. In the denominator, I get a negative 4 because this becomes a negative 1 times 4. This is my final answer for this problem. Number 18 I'm going to leave for you as a little bit of a challenge. I'm going to have 2 minus I divided by 3 plus 4i. Now this one's going to be different, and I'm going to make I'm actually going to get you started, but you're going to do all of the simplifying. What has to happen here for you to finish this problem is that you need to multiply by the conjugate of the denominator, and that is 3 minus 4i over 3 minus 4i. In the numerator, you're going to have to distribute, and same thing for the denominator. And then there's a little bit of work to clean that up. This might be one of those you want to check with other people on, but definitely give it a try before we come to class. All right, last thing we have to look at is simplifying powers of I. So for example, number 19, I'm going to give you I to the 10th power. And I'm going to show you more than one way to do this, and I want you to see the pattern that happens. If every time we get to I to the 4th, we get a positive 1, And that's because I squared squared is like -1 squared or +1. So every time we get I to the fourth, we get a 1. And when I multiply 1 times anything, nothing really changes. So I to the fourth times I to the fourth times I squared. That actually adds up to 10. So these two things are the same. Well, I to the fourth is 1 times 1. Oh, I squared is -1. So 1 times 1 times -1 is -1. Okay. Example number 20 to the 51st power. For this one, it might be a little easier to actually divide by 4, since every time we have 4 of them, so it goes in cycles of 4. So every time you have 4 I to the 4th power, you get a 1. So if I did I to the 25th power, oops, I'm sorry. Let's take that back. If I did I to the what power? To the 4th power, how many times? Well, if I went all the way to 48, so that would be 12. So 4 goes into 51 perfectly 12 times. Then this is 1 to the 12th power because I to the 4th is 1. So that takes care of that, but I still haven't reached 51. So I have I cubed. So I have this times I cubed. Well, if I remember that I cubed, oops, I wrote 13, that should be a 3. I cubed is actually -I. Then my final answer is -I. And example number 21, I'd like you to try on your own. Think about the different ways we've done that. You could do I to the 3156th power. All right. So a quick summary of what we did. We looked at the standard form of complex numbers. As A plus BI. We looked at adding and subtracting. We did some simplifying. We multiplied and divided, which involved some rationalizing. And then we did powers of I. So make sure that you're comfortable with all of those things. Review your Algebra 2. And if there's any one of those that you're weak on, that's what you need to make sure you're asking questions on. So here's kind of your checklist of what you should have known by the time you finish this video.